So, as I mentioned earlier, as you can see, this evaluation is not until Thursday. As you're writing this down, if you're choosing to, great. If not, well, then that's fine too. But is there anyone who would choose or want to come up here and work through this problem? It's your lucky day to stand on that side of the desk and tell dumb jokes and say stuff like that. Like element 2, 2, 2, 2, 2, 2, 2, 2, 2. Freshmen thought it was funny. Right? Some. What's element 2? He, 2, 2, 2, 2, 2, 2, 2, 2. Where else throughout the course of the day can you have an adult say stupid things like this? You don't. Right? So, just out of curiosity, and not that it matters whether students are going to the Science Channel and showing this. The reason that I always thought this was a good idea, okay, let's say you're working through a problem that we did in class, okay, and we could say Algebra 2 is an example as well. So as you're following Ms. Doctor along with what it is that you're doing, you might not be writing why you're doing a certain step, okay? So you're looking through a problem that you had done together on the board and working on a homework assignment. And I think it would make sense to go back and see why you put a number in a certain spot. And not that you would utilize that in Algebra 2, but I think you would agree you can see that relevance there. And so it's not that I'm looking to keep track on who or how many numbers are watching which class. It's nice to see if it's utilized, but if it's not, then we probably feel comfortable doing this. But a true measure of that would be is if we understand this, because on Friday we have you measure out two substances, suspend them in water to make a solution, and it's a double replacement reaction that you do, and from that, next week we'll use that activity as part of our percent yield that we'd be talking about in your limiting reactants. And with is it difficult to do? Well, that's going to be a relative question for some people. Um, could maybe say, well, even in volleyball, some people serve very well, maybe some people don't. Some people shoot free throws very well, maybe others don't. Um, what was it that I had seen with one of our woodwind players? A saxophone, so played bass saxophone, whatever was needed in the band. Okay, so some people can make that intuitively, maybe others can't, and doesn't mean that you're going to be bad at it. You just might need a little extra practice or a little extra help, and that's what we're here for. So, with that, is this something that you want to work through together? Let me ask you that. Okay, so a couple things with the terminology that we see. How many grams of ammonia, so NH3, are obtained? So if this is being obtained, that means we're making that. So where is that in regards to the reaction, the left or the right side? Yeah, it's a product, so it's going to be on the right side. From the reaction of 1221 grams of hydrogen reacting with nitrogen. Okay, so the next thing we need is an equation. So it's saying that the hydrogen is reacting with the nitrogen. Okay, so symbol for nitrogen is what? said it's reacting with hydrogen, which is we said we're obtaining this, or we're making that, and that's NH3, or ammonia. N2, that's right. Because gases, when they're by themselves, or halogens, remember, are diatomic. Okay, so we've got our equation now. Next thing we need to do is what? To balance that, okay? So if we've got an odd number of hydrogens on the left, or excuse me, an odd number of hydrogens on the right, with 3 and only 2 here, how do we get them to balance out, do you think? So if we double this, which I'm guessing what you had said, 2 times 3 gives you your 6 for hydrogens. So we've got 2 here, so dividing 6 by 2 gives you, and do we have to do anything to the nitrogens? The answer would be no, because now they are balanced. Okay, so if we have 1,221 grams, 21 grams of this, okay, how many grams of ammonia are produced? Well, that's what we're going to find out. All right, so we don't need this anymore. Just give ourselves a little more space. Okay. Okay, so there's only one place to start with that, and that would be, okay, so we've got 12, can you see that green? Okay. Grams of H2. Yeah, it's showing up on there too. Okay, we see grams of a substance. We're going to convert it to what? We're going to convert it to moles. So when we do that, how do we cancel that gram out? To cancel this gram out, we need to put grams of hydrogen down there. And that's for every what? It's for every mole. Now, one of the things that we had said, do we need to put a 2 here? No, we don't. And we really wouldn't have to put a 2 here, as long as you remember to double it. But remember, it's always good practice to keep carrying that, because this is how you could be off by a factor of 2. If you put 1.01 instead of 2.02, you're going to have twice as much as what you need. Okay? So these grams have canceled. We're now in moles. And this next step allows you to change what you have, which is moles of hydrogen, into moles of what instead? Yeah, of what we're looking for. Okay? So moles is here. So to cancel it out, just like what we did here, we're going to put moles of hydrogen to moles of ammonia. Okay, now, one of the things that was from last semester, remember, that was composition stoichiometry. You're just dealing with one compound. You're only dealing with one substance. That is different than reaction stoichiometry, because now we're working with 2 different compounds. So last semester you would have put a 2 here. That's why, because that's composition. That's totally different than reaction type. Because in this step, what must we do when we have moles over moles? Okay? So do we need coefficients there, which means 2 over 3 or 3 over 2? Okay, so we look at there, we got 2. Here, we've got 3 then. Okay? And then notice that these have now canceled. We're in moles of ammonia. And how do we get that to cancel? Put it on the bottom. So for every mole of ammonia, we would get 17.04 grams of ammonia. Of course, 14 plus 3, that's where that 17 comes from. All of our factors have canceled out except for our grams of ammonia. But notice, that's what we're looking for. So we know now we are done. Okay? And if we've done this correctly, hopefully we come up with 68, 67. Anyone vouch for that? Huh? Let's find out. Okay, 1221, 1221 times 2 times 17.04. Okay, 41,611. Then dividing that by the bottom, 6.06. We're multiplying these two numbers, and 68, 66.61. Right. Okay. And we rush through that really quick. Left outside, good. Okay. Right middle. It's kind of like a jack in the box. You're turning it, you just never know when it's going to pop up. Right outside. Okay. Must be jamming down to something back there. Just nod your head yes. And I would believe you. Okay? And then left middle. Okay. We're good. You just want, I can write down the answer for you, and you want to work on it on your own, or you want to work on it together like we did this one? Okay. $679. Okay. So why don't you go ahead and take a couple of minutes? Well, it's going to be more than a couple of minutes. Go ahead and work on that. And if we don't get it, work on that together. We'll figure it out. We'll work through it. All right. be absent. I'll just quietly work through this, and you can see if you get the same answer. So maybe this was a little difficult getting set up. Did anyone have the equation already? Okay, we see some yes, yes, okay. So remember, single replacement. So this is going to boot him out of there. In case you're wondering, well, how do we know which iron this is? Okay. Well, you could decide if it was bonding with another compound, we would be concerned about that. But remember, this is booting him out of there. Kind of like maybe at your winter formal. That's coming up. Let's see here. No? Well, I'm pointing at them two. Okay. So between them two, now who can we pick on in here? Oh, okay. So then, here we have a gentleman sitting all by himself. Here's Willow. And here's Lane dancing away. And then we have Adam come up and tap him on the shoulder. I want to dance. I'm going to cut in. So you replace it. Single replacement. All right. So regardless, this is a -2 times 3 would give you -6. So then that would tell you this is a +3, but which doesn't mean anything because it's all on its own on this side. We know that for two reasons. One, because it's a single replacement, we already predetermined that was being replaced. Plus, it's saying how many grams of iron are being produced. So that means it would have to be by itself. Okay. So we got aluminum oxide, still -2. That's -6. Okay. So this is a +3 charge. So then that means we need 2 of those. All right. Kind of help you out getting that equation set up, because sometimes that's the hard part about some of these problems. If you don't get the equation set up correctly, it doesn't matter what you do beyond that. It's going to be incorrect. Okay. One of the ways we can look at that really quick is notice that aluminum and iron have the same charge. So since that's the case, you have the same number of oxygens on both sides then too. think it's set up correctly now. And let's see if we hit our target of 679. Oh dear, I made a mistake. Before we go any further, made a boo-boo. I will see if anybody was paying attention. Anybody else catch that? This was the answer, 679. So now, let's see if we can get that. Something's not right here. And let's make sure I looked at the right problem here. Okay. That's right. So we'll need to change that. Holy cow, that changed a lot. I did that on purpose. Can you believe that? Okay. So we start over again. How many grams of iron oxide are needed? Okay, so we have that many grams of iron. Okay. Gives us a mole of iron. Okay. Therefore, we know we've got 2 down there, 1 up there. Okay, now let's see what we get. Yeah, 686. But I took this times 110. I just took 55 times 2, so that's going to be off a little bit instead of 55.85. So that's got to be right there. All right. Are we good? All right. So we'll discuss that activity tomorrow, problem quiz on Thursday, and we'll work on that activity on Friday because we'll be utilizing that next week. Catch up to you next time.